Hello, everyone. My name is Russell, and today I will be presenting on the Low Powered Wide Area Network, or LPWAN, for the SC3010 Advanced Computer Network presentation. I will be covering these 6 sections for the duration of the video. First, I'd like to break down the definition of LPWAN by starting to define its meaning of low power. It is defined as objects that provide power that feature particularly a focus on extended use and energy conservation. Some examples include small batteries and solar power. Secondly, wide area can be defined as a network that supports long distance in between as short as 2 kilometers to a global coverage. Combining these two definitions together with the network, it is the result of an unorthodox combination of decades of computer network research and development. As a result, the birth of an innovation that pushes the boundaries of network technology to new heights. LPWAN has characteristics that include but do not limit to its efficient use of power, being the result of small power sources utilized, which tend to last longer and ration energy more efficiently. Secondly, comes its ability to cover long distances. Thanks to modulation techniques alongside its use of reduced frequencies, coverage is enhanced alongside a mitigation towards malformed data being transmitted. The next benefit was most unexpected, but not unwelcome. Due to the low cost and small size of the hardware involved, it has become easy for a sheer number of nodes to be deployed, which require the network to be scalable to deal with the rising additions. Unfortunately, one of the most glaring characteristics was its inability to transmit large bandwidths of messages. Instead, only small-scale messages are sent out to ensure LPWAN's efficiency. These characteristics truly do make LPWAN stand out as a worthy candidate in the pantheon of existing network structures. As shown with the graph, while it does have the highest range, it suffers from the drawbacks of the lowest bandwidth transfer, a consequence due to the limitations of it being a low power and wide area network. LPWAN architecture can be summarized down to 4 critical components that are integral towards running the network. The first being the nodes. These sensors, actuators, or objects are deployed across the surrounding area to gather data to be sent towards the LPWAN network. Data sent is then obtained by the gateways and concentrators, which deal with the ever-growing number of nodes added. Concentrated data is eventually forwarded towards the core entity, being the network server, where it is processed and secured before being funneled towards the final part of the network. That being the application servers, where the data is churned and displayed for potentially data-driven situations or decisions. That is how it is structured in general. And of course, due to its development, there are multiple types of technologies that have emerged which have served their unique purposes. The first being Sigfox, which specializes in communication through urbanized environments. The second being NB-IoT, priding itself for having the best service quality out of all LPWAN network types. Lastly, long-range wide area networks or LoRaWAN, an amalgamated attempt to synchronize the definable standards which future developments of LPWAN will follow on. The deployed technology shows LPWAN has seen great potential in being utilized in real-world applications. Examples include being used in environmental and climate monitoring scenarios where extremely isolated locations can deploy with minimal human interference. The increasing connectivity of technology has stewarded the concept of Internet of Things, which LPWAN is seen as a network that effectively binds all devices together. Despite all the greats of this piece of technology, unfortunately, it still has many pitfalls, which has to be improved upon if it's to be the gold standard of network technology. The first being the performance affected easily by mobility. LPWAN works better when it is on a standstill as compared to its cellular counterparts. The second is having inadequate security. Its lightweight nature makes it more vulnerable to cybersecurity attacks due to a standard security issues. Finally, bottlenecking, which is defined as having a build-up or congestion of data waiting to be processed. The limited power of LPWAN makes it susceptible for long wait times due to process the large amount of data that is being transmitted. Fortunately, its ability to potentially merge and enhance big technologies such as big data and AI to maximize their reaches across the globe has warranted its much needed research and development to reach its fullest untapped potential, which outweighs and perhaps even overcome the aforementioned limitations. With that, I've come to the end of my presentation. Thank you.